Okay. You have 2 pipettes. We are going to get hypothetical here and say these pipettes are both 200 milligrams and they are both filled with coffee to 200 milligrams. Okay? Hopefully you are with me so far. This pipette weighs 100 grams. Okay? This pipette weighs 125 grams. So mass over volume is going to give you your density. Density equals mass over volume. Okay? So I've done this so that it's very easy for you to see. Now, which one, you don't have to answer because I won't hear you, of these is more dense? You're right, this one. I heard you. This one is more dense than this one. Okay? Now let's pretend together, shall we, that each one of these grams is actually 1 seed. Okay? So if each one of these grams represents 1 seed, which it would not in real life, it'd be closer to 7 to 10. But if each one of these seeds represents 1 gram, or each one of these grams represents 1 seed, then this pipette would be filled with 100 seeds. Following? That would mean that for the same amount of space, there would be 100 seeds filling this, but each seed would have to weigh 1.25 grams. 1.25 grams, okay? So 25% more than the sister seed over here. Now what if I then took a moisture measurement on these 2 coffees? And both of these coffees read 10%. Let me put that in a different place. What if both of these are 10% moisture? Now, if I measure just moisture and I go off of that, then I'm going to assume that I'm going to need to roast both of these coffees the same way. But I don't need to assume that because I've measured the density of the coffee. Okay? And the density of the coffee tells me that these are different. Now, moisture can be a component of density. Okay? So I'm not saying that the moisture within the coffee is irrelevant, but I'm saying it's only partly relevant. It's part of a whole picture, and the whole picture can be seen much more clearly when we have mass over volume, when we have that density reading, okay? If you have a really nice density meter, generally there should be some kind of component. If it has a volumetric component, which a lot of them will have a tube that comes with it, that volumetric component can be used to give you a density reading, which is usually bushels over pounds or something like that, so that you can start charting your density on your coffees as well as your moisture in your coffee. So now, if this says 10% and this says 10%, we know that this one, by nature of being more dense, 10% of 125 is more than 10% of 100 grams. So I know that here I have 12.5 grams of water, and here I have 10 grams of water. So even though my percentage is reading the same, my percentage then I can use mathematically, do some algebra, and you can look at exactly how much water you have in that particular coffee, okay? So that's why the percentage of moisture can be very misleading, okay? Furthermore, as you are going through yellow, and this is where we're coming back to reality here for our drying stage. As you're coming back through yellow, pretend like this is our graph. Remember, it falsely has the turnaround. As you're coming through yellow, whether or not you have 12.5 grams or 10 grams, you're going to drop down to about 0.5 to 1.5% moisture during that stage. You're going to dry out enough, hopefully, if you go through the stage correctly and then start moving through your browning reactions correctly enough to where this moisture is going to be out of the way. If this moisture is present, you cannot have a browning reaction. Okay? Browning reactions, by definition, are dehydrating reactions. That is when your molecules are losing H2O components off of the molecule and your molecules are breaking down. So if there's H2O present at that time, you cannot have the Maillard reaction and you cannot have caramelization, okay? So that's why drying is so important. We need to get that moisture out of the way. Use the moisture while it's there to pull energy into the seed. Once that energy is there, we release the moisture, we have more airflow, and we can move through the next reactions, which come back next month, and we'll talk about those. Any questions? I'm sure we've sparked some more.
Milliliters.
Yes.
Not milligrams.
Milligrams, exactly. This should be milliliters. So sorry.
That one's for you, Rob. There you go.
And just point of clarification, milligrams and milliliters are virtually the same with water. But with coffee, obviously coffee is a lot less dense than water, so you'll have a lot fewer grams per milliliter with something less dense than water. But yes, sorry about the milligrams. I don't know what I'm thinking.
We often don't either, but. Anybody else have anything else? Now we have to wait for the delay.
It's okay.
Yeah, we'll just hang out.
We're going to hang out for a second, wait for the delay. This is going to be awkward because you will have already been through the delay by the time you hear me talking about the delay. But it should pay off in case we have any other questions.
It's only going to be like another 5 seconds. YouTube's. What, we give them 20 seconds to type?
Mm-hmm.
Should be like right now. And we're calling it.
All right.
Roaster School.
That's it.
2.
Episode 2 of Roaster School is out. Please hit us with your questions for episode 3, which is going to be on your browning reactions as we're moving from yellow to first crack. I'm not quite sure whether first crack is going to get its own episode or whether that's going to be included in next week. We'll just see how next week goes. Thank you. Please come again. Get better, Dave.
Bye, Dave.